All right, welcome everybody. This is our session 1, grade 11 preparation. And this is so important because it's a merge of grade 11 and grade 12 together. Is that okay? Grade 12 in your junior exam, you'll be tested on grade 11 concepts. Things like electrostatics, electricity, Newton's laws. Okay, grade 11, it's very, very fresh. Grade 12, this is very important because most of you have forgotten all of these things. Quite a lot of things. Okay, so I'm going to be bringing you back up to speed as we prepare. When I'm done, this will be posted on YouTube. You can just follow through there. So subscribe, like, comment, and share so that when we post things like this, you are able to see, get notifications. Okay, just leave some 5 stars as well. You know, it's important for the social ratings. Welcome. This is Crazy Physics. All right, let's get work on. Now, I'm going to start with this. I'm going to start with this. And this has to do with forces. Look, my dear learners, the most important thing is to remember how to find vertical and horizontal component. I cannot overemphasize that you should know how to find vertical and horizontal component. Grade 11s, this is mainly for you. Okay. A pulley system is used to keep a heavy object at rest as shown in the diagram. So we have this heavy object and there's what you call free body diagrams as well. I'm sure you all know. Okay. Define the term resultant vector. It is a single vector that has a combined effect of 2 or more that you must know. The word resultant could be interchanged with the word net. All right. And that's why we write Fnet. A single vector that has the same effect as 2 or more vectors. So even if you have 100 vectors, you can combine them together into one. And we call it Fnet. A single vector that has the same effect as 2 or more vectors. All right. I hope we are good there. Now, if I ask you to draw, okay, this examiner says draw a vector diagram showing the forces acting on the object. A vector diagram tells me I'm not going to use a dot, I'm going to use a box. So if I were to draw a vector diagram, I'll be using a box. And I have to show these forces exactly where they are. That's the difference. If it was a free body diagram, what will I be using? A dot. Now, how many forces are acting here? Don't worry about this one that you see going up and going down. You see this thing here? This thing here, don't worry about it going down. It's just here. It's the same force. All right? It is the same force. So, what are we going to have? I have one force hanging to the right. I have one force to the left. Oops. I have one force to the left. But this object has a mass. And if it has a mass, it must have what you call what? A weight. And if it's a vector diagram, the weight comes from the center. And we label. This is the weight, or which you call the what? The force of gravity. And what is this force? This force is 1,284, what? 95 newtons. What is this force? 1440 newtons, all right? But hold on, there's something remaining. We said we are showing the exact positions. It means I must show my angles. We are showing the exact what? position. So I must show my angles. For a free body diagram, we don't show the angle. So what is this angle here? 40 degrees. Okay, guys, if this is 55, what do you think this angle will be? Because we're showing from the vertical now. 90 minus 55, which is what? I know you are looking for calculators. 90 rand minus 55 rand will be how much? 35 rand. You see, when I put rands, we quickly get it done. All right. So you must show that angle. And what is this angle here now? 35 what? Degrees. You have your 4 full marks there. The forces and the angle. But if it's a free body diagram, do we need the angles? Nope. We just need the forces. All right. Calculate the weight of the object. Ooh, easy question here. Guys, I'm going to use this to quickly remind you of how to calculate your components. Components. Okay, so how do we calculate? Let's draw a full free body diagram now. Full free body diagram. I'm going to go to the next page. A full free body diagram. What will it look like? All right, check. Please, this is where, if you get this now, physics becomes metlit. Bombastic side eye. All right, that's my weight there. What else do I have? All right, guys, check this, please. I need us to move. We have that force and we have that force, right? This was 1440 what? Newtons. Do you remember this value? Did we write it down? Let's go. It's what? 1284,95. 1284,95 newtons. All right. Great. Now, please take note. We always resolve inclined forces. It's a must. We always do what? Resolve. I'm going to write it there. We always, let's write it in capital, resolve what? Inclined forces. When we say resolve, it means we change it into components.
Sir?
Yebo.
Is it inclined?
Yes. Inclined means it's at an angle.
Okay.
All right. Inclined. Inclined forces. We change it into components. And what are the components we are looking at? We're looking at what? Vertical and horizontal. So when you say something is inclined, it means it's at an angle. It's no longer vertical and it's not what? Horizontal. By the way, we do know this angle. Do we remember this angle? 40 and 35, right? So this angle is what? 40 degrees, and this angle is 35 degrees. Okay, guys, I want to now do my components. One easy way that I do my components is to use your normal compass. North, south, what is this? East and west. Let's call this force number 1, and let's call this force number what? 2. Let's deal with force number 1. In which direction do you think force number 1 is pointing? Not west. You want to travel? Not west. Yes, not west. It means when you do the components, what are we going to have? Vertical must be going north. Horizontal must be going west. So I'm going to have a new diagram. Check. Once you understand the free body diagram, life becomes sweetest. Check there. West and north. Does that make sense? So I'll call this F1Y and call this F1X. Just your normal Cartesian plane, Y and X, right? Good. Because we need this also when we talk about F net equals to MA. Lovely. I want us to deal with F1Y and F1X quickly. Watch what I'm going to do here. I want to make your life very easy. This is my F1Y. Let's complete a right angle triangle. Where's the F1X going to be? There. We want to complete a right angle what? Triangle. And that is 90 degrees. This one is the X, right? While this one is the what? The Y. The one that is opposite, we use sine. The side opposite the angle, use what? Sine. Please, I need you to have clarity. I have this like this. What is this angle here? 35. Which one is this? F1X. Why? It is horizontal. This one is my F1Y. What is this? 1440. Which one is opposite? It's X. So it means my F1X would be 1440 sine 35 degrees. The one that is opposite, we use what? Sine. Once you get that, look, we're just going to repeat this over and over again. F1X is 1440 sine 35. What is F1Y? That one becomes cos. Now we're doing trigonometry. This is why you cannot separate math and physics. It's even worse in grade 12 when we start calculus. You cannot separate them. What is F1Y going to be? 1440 cos what? 35 degrees. Does that make sense to us? Okay. If you guys are okay with that, you will be doing the next one for me. You will be doing the F2. Don't worry about finding answers to this one. Just leave them for now. Can you find F2? Okay, where is F2 pointing? Northeast. So it means my F2 will be pointing in which direction? To the north. And the horizontal will be pointing where? To the right. So what do we have? F2X and what? F2Y. I want you to quickly tell me which one is sine and which one is cos. Which one is sine and which one is cos? Is it the X? Some people will say X is always cos. There's no always here, please. The one that is opposite, that's where the always is. The one that is opposite is always what? Sine. And should you forget, just think about your SOHCAHTOA. What's the formula for sine? Sine theta is what? That's the first I'm looking for. Sine theta is opposite. So the one that is opposite, we use what? Sine. That's all. Okay, I see answers coming through. A lot of answers are coming through right now. No, you should complete the triangle by yourself. So if I were to complete this triangle, what would I have? I'll have that, right? Good. And which one is this? And it's the one opposite, right? So F2X becomes what? Sine, because it's the opposite one. So what do we have? F2X would be what? 1284,95 sine what? 40. What about F2Y? 1284,95 cos what? 40. Obviously, I do have my weight. Are we okay there? Look, once you get to this point in physics, the rest is, physics is done. Once you get to this point, don't hate me, physics is done. At equilibrium, F net must be equal to 0. And what do we mean? All the vertical forces added together must give you 0. All the horizontal forces added together must give you what? 0. Now, how many forces are pointing upwards? 2 of them. How many pointing downward? 1. It means these 2 pointing up must be equal to the 1 pointing what? Down. Because the object is at equilibrium. And when do we have equilibrium? We have it in 2 things. Number 1, object is moving at constant speed. We know that at constant speed, acceleration is equal to what? 0. So F net will be 0 there. All right? Or, what's the second one? Object is what? Stationary. Object is at rest. If the object is at rest, we're going to have the same thing. F net will be equal to 0 because there's no velocity. So we must just know when F net is equal to 0.
Sir,
Hi.
I have a question.
Please do ask away.
Sir, remember you used to say that we should resolve the angle, and when we do that, sir, we should look from the horizontal, sir. So for F2, sir, why don't you say that it's 1,285.95 sine 50?
Sine?
50.
Okay. Darling, it will give you the same thing. Because sine 40 is the same thing as cos 50, trigonometry, co-functions. Sine 40 and cos 50 would give you the same. Okay, check this. Let me ease your mind. If I were to do this, right? Sitley, are you here?
Yes, sir, listen.
This angle will be what? 50 degrees, right?
Yes, sir.
Okay. Now, I hope you won't get, it's not going to be too messy. Let's do it on a different page so that it doesn't become too messy. I won't draw very lovely diagrams now. So we have this. Is that fine with you? And we have the horizontal. This angle is what? 50 degrees. This one is going to be my F2 what? Y. Is that fine with you? Now, this one, because it's opposite, is going to be what? Sine. Do you agree? Okay. Give me the value on this force again. 1 something something. 128, comma. All right, check. We're going to do trig now. What is F2y going to be? We said you're going to use what? Sine, right? So it's going to be 1284.95. Sine which angle now that I'm using? 50. What was the answer we got for F2y? Don't give me just give me the expression we wrote. 1284.95. Cos what? 40. Sitley? We're going to quickly revise trig. These two are equal. Because 50 plus 40, we say they are complementary. Here we talk about co-functions. So your answer would be the same. Do you agree now?
Yes, sir. So I think I realized what my mistake was. I swapped sine and cos.
Aha. So all you need to remember is that if it is opposite, we use what? Sine. You good? Okay. All right, my dear learners, let's finish this question. What will be the weight? The ones upward together must be equal to what? The one downward. So can we say F1y plus F2y equals to what? Fg. You do the maths now, quickly. F1y plus F2y equals to what? Fg. Please do the maths. The maths must maths now. We have our values. We are only substituting. If we can keep your mics muted until you have a question. All right. Tokelo has 2163,91 newtons. Do I have a confirmation? 2163,91. And guys, that's how we deal with Newton's laws. It's just easy like that. Wait, what are we looking for? Are we looking for the weight or the mass? Okay, lovely. If we're looking for the mass, then we use W equals to what? Mg. Okay, done. You said your answer is, so what are we adding? We're adding this and that, right? You said the answer. Give me the answer again. 2163,91. Remember, without a unit, you lose the mark. 2 decimal places. Awesome. Okay. I move on now to the next one. All right. These are the things now that grade 12s you will be welcomed with in question 2. This is your question 2. Okay. Grade 11, this is your question 3. 2 block of mass. Look, this is where we get things wrong. Right now, all of you, what you are reading is 3.1. Everyone 3.1. Please, don't do that. Stop. I don't know what I'm going to do to make sure you stop doing that. I'm going to put cameras on your papers such that until you read that part, that thing doesn't open. Yeah, we need to write electronic papers. All right, please let's read, and I'll show you why it's important to read. I'm going to highlight a few things for you. 2 blocks of masses. That's my first thing I'm going to highlight. Masses tell me there's a weight. Is that okay? Fg. 5 kg and 2 kg are connected by a light, inextensible what? String. String tells me there is what? Tension. All right. A force F is applied. I know there is an applied force. On which object? On the 5 kg at an angle of 20 degrees to the horizontal, and the system of blocks accelerate to the right at 2 meters per second as shown in the diagram. The kinetic frictional force, there's friction. Is that okay? All right. Is on the 5 kg is what? 10 newtons. Define the term normal force. Your definition is, remember, it's 2 or nothing? Nothing. 2. Normal force. A force exerted by the surface on the object. And it is what? Perpendicular to the surface. It's okay. It acts perpendicular. It's saying the same thing. The key word is that there must be surface, there must be object, and there must be perpendicular there. Done. Anyway, everybody, draw a free body diagram. We're going to mark that quickly. You have 30 seconds. Quickly draw yours. Thank you, Sitley. Everybody draw. Once I mark now, once I draw mine, we would mark. We should be done now. All right, I am drawing mine. We need to save a lot of time. On the 5 kg, the first thing I see that the 5 kg is on the table. It's on the surface, rather. And if it's on the surface, what force are we looking at? Normal force. Lovely. Lovely, lovely, lovely. Okay, good. Let's draw. Please, as much as possible, try to use a ruler. Just respect physics a little bit. Okay, in an exam. Force applied. My normal is that way, right? Okay. Where is my tension? To the right or to the left? To the left. Because it's been pulled by what? The 2 kg. Okay. Where is friction? Right or left? Huh? Why left? Please talk to me. I need to hear this. Where is friction acting? To the left. What is the reason? To the right. Lindo, why to the right? Explain. Because some people are saying to the left, some are saying, I need us to get this. So, wait, Lindo, say that again. Let me increase my volume. This is sounding lovely. Yes, talk to me, Lindo. I want to hear you.
Sir, friction works against the direction of which the tension is being pulled. It opposes the direction of motion.
Okay, you see that first statement you said, delete it. This last one you said, we'll accept it. Okay, friction acts opposite the direction of what? Motion. How is the object moving? To the left. Where's your left hand? Your left hand on your left side. Okay. All right, child. This is the right side. Do we agree?
Yes, sir.
And this is the left side. Do we agree? So how is the object moving? So that we are all on the same page. Because like right and left now. Where is it moving? Right or left?
So I think it's being pulled on the left side.
Okay. What is this? Lindo?
Can I try to answer?
No. Okay. Wait. Let me get Lindo's first. Lindo, what is that? The one I circled.
The force applied.
Okay, wait. Hold on. Can we go back? Let's read. It says, where's my highlighter? Let's read again. A force F is applied on 5 kg. Is that okay? And the system of blocks does what? Lindo, read with me. Accelerate where?
To the right at 2 meters per second minus 2.
Okay, so where's the object moving? Is it right or left?
To the right hand side, sir.
Good. Object is moving to the right. So where is friction?
To the right hand side, sir.
But you just told me now that...
No, left.
Huh? Linda, you're making my day. All right. You're making my day. Lovely. I love this type of interaction. Okay, but let's get you sorted. Friction does what? You got it right by saying what? opposes the direction.
of motion.
Good. It means if the object is moving to the right, friction must be moving where? To the left. Oppose means opposite. We okay?
Yes, sir.
All right. Thank you very much. Linda, you just gave me a very good evening. Lovely. Thank you so much for that interaction. Now, to everyone, this is what I want to tell you. Never ever use the direction of applied force to judge friction. I want to surprise you. Friction and applied can act in the same direction. Nasia, you look like, okay, no, hold up. That's what you gave me, a bombastic side eye there. And you look surprised with that statement. You look surprised too, Naseba. All right. Let's clear that quickly. And that's why when we define friction, do you notice that in this statement that we have here, there's nothing that talks about applied force? Friction doesn't oppose applied force. Friction opposes what? The direction of motion. Let me create a very simple example. I love this example so much. Check this. Check this. I'm in the mall. Is that okay? I am in the mall, shopping. I'm shopping. Okay. This is me here with my nice hat, the nice cap there. I'm shopping. Can't even draw a trolley. Okay. I'm shopping. Oh, I got it right. Shopping. And it's so full. It's so heavy. But a plasma. But what? But a washing machine. But everything. I just got paid. It just bought all kinds of stuff. Things Standard Bank mistakenly paid me 2 million. So I had to spoil myself in the mall. This is me pushing the trolley. Is that okay? All right. I want us to talk about my applied force. Since I am pushing, where's my applied force? Force applied, right? Okay, where's friction? I am moving to the right. We all just agree that friction opposes what? The direction of motion. So it means my frictional force, or the friction acting on me, should be to the left. Do we agree? Okay. Then because I love this diagram so much, I want to keep it. I may not be able to draw another. Oops. Okay. Now I'm facing the other way. Now, check this. No, I thought I grouped this thing. Mirror image. There we go. All right, don't worry. This smart board is my baby. I know how to deal with it. Flip it back. Yeah, bo. Got you right. Delete. That's me. Exact me. Oh, the wheel came off. All right. Check this now, guys. I am now here. Oh, can you see physics? Interesting. What will I be doing to that trolley? Will I be pushing or be pulling? I'm pulling. Okay, good. Since I am pulling, where is my applied force? It's coming towards me because I'm pulling. Lovely. So, what is this? Force what? Applied. But where is my direction? So, where is friction? We said friction should oppose the direction of motion. So, since I am going down the plane, where should friction be acting? Up the. Are you aware that it is exactly in the same direction as my applied force? That's why we said we don't use applied force to judge what? Friction. What is friction? It's a force that opposes the direction of motion. Everybody, Did it make sense? Please, that's a very important concept. Because do you know the funniest thing is, when you get your free body diagram wrong, it affects your science automatically. All calculations under it will be wrong. Like every single calculation you do from there to the windows. Okay. Guys, did it make sense? Please let me know. Let me know quickly. You have 10 seconds to respond to your understanding there. Thank you, Nelly, Angela. Come, I need all the responses I can get. Thank you, Divine. Tanisha, you raised up your hand. I don't know if that's saying you understand. Thank you, Pule Kumo, Kensani. Thank you, Minenkle. Lovely. And everybody made sense. I'm glad. If that's the only thing you learned today, it's worth your while. Because it's going to affect you. Grade 12 learners that are here, it's going to affect you working energy and power. Free body diagram. Grade 11 is going to affect you in Newton's laws. So grade 12, it will affect you 2 times. Grade 11, it will affect you 3 times. It will affect you in Newton's law this year, Newton's law next year, working energy and power next year. So please, let's get that sorted. All right, can we go back to our question now? All good. I really love this diagram. Oh, I look like an artist. And that I got by chance. Trust me. But awesome. Okay, can we then finish our free body diagram? So we dealt with that because of friction, right? Okay, so where's friction now in this case? Friction is to the left. Why is it to the left? Because the direction of motion. And please don't do this because you want space. Don't do that. It must be parallel to the surface. You see, is that parallel? No. Please. It doesn't matter if they are on each other. Is that okay? If you want to draw really, really parallel, okay, you want to move it that way. Okay, mine is not now a bit skewed. All right, it's now a bit skewed. Let me just draw it again. You know what you could rather do? Make the dot bigger. And then, that's why I said, please at least try to use a ruler. Make sense? Parallel, please. All right? One more force is missing. Force of gravity. By the way, this should be long in this particular diagram. This is the force of what? Gravity. Let's move quickly. What is this? Force what? Applied. What is this? Normal force. What is this? Tension. And what is that? Friction. All right, you have your 5 marks, everybody. 5 marks. Calculate the tension in the string. Tension in the string. Let's look at the objects. If I don't know F, that's going to be a problem. What about the 2 kg? Look, it's 3 marks. When you see 3 marks in physics, I'll tell you the secret. 1 formula, 1 substitution, 1 answer. Bam, bam, bam. There's no simultaneous story here. Now, if I look at the 5 kg, I have too many unknowns. I don't know force applied. I don't know tension. Can we try the 2 kg? All right, quickly, 30 seconds, draw the free body diagram of the 2 kg. 30 seconds. Free body diagram. Free body diagram is the key. All right, we should be done. We should be done. Okay. So, if I were to, can I draw mine now? How many forces do you see acting? 2. There's no normal. Please. Why is there no normal force? The object is not on a surface. All right, because I've heard some learners, I was in one school say just draw all the forces. Like, hey, are you aware that when you draw additional force, they subtract one? For example, if the examiner says draw the force free body diagram of the 2 kg, and you decide to draw normal force, you'll get 1 out of 2 marks. Because your normal force is simply cancelling out the mark you got. When there's an additional force, it's -1. All right. So now you know. So you don't just draw. Okay, what do we know? The weight and what? Tension. All right. Tension is going up and the weight is going down. Lovely. How is this 2 kg moving? Is it up or down? The 2 kg. Remember, we pull in that one. So the 2 kg is moving where? Up. Guys, I always take the direction of motion as positive. It makes life easy for me. So this one will be what? Positive, and this one will be, can we use our Newton's second law? F net equals to what? MA. Which forces are acting? 2 of them, right? So what do we have? Positive T plus negative FG. Does that make sense to you? Equals to what? MA. T minus mg equals to what? MA. What is the mass again? 2. What is G? 9,8. Please, guys, don't change the settings. I see someone is now playing around with the settings. You're going to affect every other person. So please, let's keep my settings this way. All right. Let's keep my settings this way. Thank you very much. What is the mass again? 2. Do we know the acceleration? 2. Oh, sweet. So what do we have? T minus 19,6 equals to what? 4. What is T going to be? 23,6. You're wrong. Newtons, correct. Yes. All right. I think life is made easy with that, right? The answer is always in your free body diagram. Quickly, let's get to the next question. Calculate what? The force F applied. Guys, it is force F. You have no business on the 2 kg. Is that okay? You've got no business on the 2. But we have a problem. Do you know what my problem is? Force applied is inclined. We need to find the vertical and the what? Horizontal. Where will my vertical be? Up. Where will the horizontal be? To the right. Okay, let's quickly get that done. Now you guys are enjoying physics. Do you see? People think I'm smart. I'm not smart. Physics is easy. That's the thing. Okay, I'm having all kinds of sounds here. Guys, it's not that we're smart. Physics is just easy, you know? Physics is the new LO. All right. I'm going to use a different color to show this. We're going to have right. And we're going to have what? Up there. Make sense, everybody? All right. Can I call this Fy? Can I call this Fx? Tension. What do I have here? Friction. What else do I know? Normal. And what? Fg. What are the things that I know? Yes, Tabs, your hand is up. If you want to talk to me, you may quickly. What are the things that I know?
So I wanted to ask.
Yes, please do.
When I calculated tension,
Yeah.
I just assumed that it was 19,6, and then I just assumed that the upward force is the same as the bottom force, like the force acting upwards.
Okay. I like the word you used. You just nailed yourself. You made an assumption. Okay, you cannot make such in maths and physics.
Because I always thought of it as the same way as how, say for example, if you were going to calculate the normal force on the 5 kg,
Mm-hmm.
equate it to the force of gravity at the bottom. So
No.
why is they wrong?
No. Tabs, you cannot just equate. You have to use your free body diagrams. It depends on the number of forces that are acting on the object. Look, for example, in this case, it's wrong for me. We're about to get there. It's wrong for me to say normal is equal to Fg. I would be messing physics up.
Right.
In fact, Newtons will appear. Yes, Newtons will appear in my dreams and chase me tonight. If I say normal is equal to Fg in this case, you'll see me sweating tomorrow. What happened? No, I saw Newtons. He was chasing me around with a stick. Okay? So you look at your free body diagram before you jump into any calculation. Are you with me? All right. So watch what I'm going to do on this particular one. We're just about to get there now. We are about to get there. Normal and Fg. All right. Quickly, everybody. So Tabs, just keep your eyes open. I'll ask you again just in the next 2-3 minutes if you're okay now. So we don't make that assumption. We work it out. All right. What information do I have? Do I have friction? I think we have it. 10 newtons, right? Lovely. Now, I want you to help me, my dear learners. Give me the formula for Fy and formula for Fx. I'll do that on my diagram. What is that? Fx, Fy. You always complete and use the diagram. Fy, Fx. What is the formula for Fy? Remember, it's opposite. So it is F sine 20. All right. So my Fy is what? F sine 20. What is my Fx? F cos 20. Make sense? Once you get to this point, you would see that it's physics is just, you just smile now. All right, you just smile. The object is still accelerating in which direction? To the right. At an acceleration of what? 2 meters per second squared. F net equals to ma. Positive, negative, negative. F net equals to what? MA. What do I have? F cos 20. Is that fine with you? Because net means total. Plus, I always like the plus, to use the plus sign. Because net means I'm adding. But what am I adding? Negative tension, right? Why is it negative? Opposite direction. Plus, now I sound like clientele. Plus, negative FK. Plus, equals to MA. Now, what do I have? F cos 20. Do I know my tension? Minus 23,6. What's my friction? 10. What is the mass? 5. What's the acceleration? 2. Please do the maths. Get me F. Let's check your maths quickly. Whether you're doing maths or maths lit. All right, do we have answers? I'm getting on the group, online, I'm getting 46, okay. Secondly, what are you typing? You have 46,9, then you have 40, then you have, okay, can you give me your final answer? But I see 46,4. And quite a number of people are agreeing. Okay, 46,4, which is wrong. 46,4, thank you, please. So F is 46,4 newtons. All right, quickly, let's move. I like the pace we move because this is where physics really dies, you know. Next question. What are we looking for? The coefficient of kinetic what? Friction. Do you remember the formula for coefficient of friction? All right. Fk equals to what? Mu Kn. Can I just use so that I don't go into a new page? Fk equals to what? Mu Kn. This is where examiner wants to finish you. I promise you. Do you know where? Normal force. Guys, this object is moving horizontally. What does that tell you? The vertical forces are at equilibrium. Is that okay? Object is moving what? Horizontally. The vertical forces are at equilibrium. If the object is moving horizontally, vertically rather, it means the horizontal forces are at equilibrium. Please write that down. It's going to help you. If object is moving horizontally, the vertical forces are at equilibrium. And vice versa. Speak French. All right. Guys, we cannot just substitute mg as normal. Tabs, this is now for you. Okay. We are saying the vertical forces are what? At equilibrium. What does that mean? We did that in question 1. The forces going upward must be equal to the force going where? Down. How many forces are going up? 2. So what do we say? Let's go look for normal force. N plus Fy should be equal to what? Fg. What is my normal force? It is Fg minus what? Fy, which is mg minus F. What is our y again? F sine 20. So let's calculate normal. What is the mass? It is 5. What is g? 9,8 minus, do we know F now? 46,4 sine what? 20 degrees. Do you want to give me an answer? Please do give me an answer there. Sorry? 33,13 newtons, remember? So what is my friction? We know the friction, right? What's our friction? 10. Mu K, 33, what? 13. So what is my coefficient now? 10 divided by 33,13, because we divided both sides by 33,13. 0, 10 divided. No, we divide both sides by 33,13. Your answer should be 0, All right. What is the unit? What is the unit? In physics, you must write unit. It's a must. It's a physics. If you don't write unit, it's 0. So what is the unit? All right. Guys, it has no unit. And what is the reason? It's a ratio. That's an exam question. It has no unit. All right? No unit, because it is, thank you, Sikulile, it is a ratio of forces. That is an exam question. Why is it that coefficient of friction has no unit? It's a ratio of forces. Before I go to the next question, oh, by the way, Tabs, are you okay now? I almost forgot.
Oh no, I do understand. I get it now.
Okay.
19.6 would be correct if, your acceleration was 0, it was constant.
Absolutely. Now we are doing physics. Thank you. Okay. Guys, just before I move on to the next question, just quickly want to share something with you on this mu k. Number one, we said it has no unit. Why is it having no unit? We said it is a ratio of forces. Okay? It is a ratio of forces. But this is not what I really want to share with you now. Now we know that. Please take note that a change in the angle, a change in the angle of inclination. I think today I'm just doing Newton's laws because I added a few more questions. A change in the angle of inclination does not affect mu k. An examiner will tell you, let's increase the angle of the surface. How will it affect the coefficient? It doesn't. Reason is this. This thing tells you about the degree of the roughness of the surface. So even if I change the angle, have I changed the surface? Nope. The only thing that can affect this is if you pour oil on the surface. All right. We can actually watch someone's TV by listening. Okay. All right. Guys, a change in the angle does not affect what? The coefficient, because it's still the same surface. It's as rough as it is. If you do nothing to the surface, nothing happens to what? The coefficient of friction. Whether I change the angle or not. Yes, friction is affected, but not coefficient of what? Friction. Okay. I think I got something nice next. Okay, 10 marks. Let's quickly walk through. A rescue helicopter is lifting two people upwards as shown in the diagram below. The tension in the cable is 1205,4 newtons, while the helicopter does what? Ascends at a constant speed. What do we know about constant speed? Beautiful. At constant speed, acceleration is equal to 0. Don't limit it there. F net also is equal to what? 0. Grade 12, work net is now also equal to what? 0. Okay, grade 11, we just stop here. And this is a grade 11 class, so we leave that. Newton's second law in words. This is so beautiful, guys. You need to state this every day. I promise you. Naseba, when mommy calls you at home, please say ma. Do you know what mom is telling you? What is F net? F net equals to what? It's not MA. F net equals to what? Ma. Naseba, ma, when a net force acts on an object, just start immediately. You know how many times you'll be defining? About 50 times in 1 hour. Mothers love physics. They love revision because they keep calling you. The remote is just right here. Bishop, ma, get me the remote. You can stretch, ma. As you're walking away, Bishop, ma, get me a cup of water. She's only telling me, revise. It's the longest definition in physics. But please tell her that every time she calls you, she must understand that you're not talking back. African mothers will slap you. Okay, so you must tell them, no, when you call me, I'm going to be using your call as a way of revising. Otherwise, they'll think you're talking back at them. And, whoo, I know Indian mothers too, right? Yeah. My mother will just throw anything with her, a shoe, a stick, whatever it is, and she doesn't miss. Okay. So please, it's just a way of what? Revising. When they call you, just when a net force, even if you cannot say it, just think about it now. When a net force acts on an object, what happens? The object will accelerate in the direction of the net force, and the acceleration is what? Directly proportional to the net force and inversely proportional to the... Look, it's so sad that when we go for matric marking, we still find people missing that or leaving it empty. 2 marks gone. I mean, get 2 out of 150. If that's all you're going to get. It's a saying. But you find a learner leaving that. I want to mark the paper, and this learner got 3 out of 150. 3. 1 mark every hour. Sat down for 3 hours. 1 mark. 1 mark. I promise you. 1 mark for the first hour. Second mark for the next hour. The third one. All right. Last hour. Just to compensate the hours. Okay. All right. Let's do this. Calculate the what? The combined mass. Again, you know what makes this easy? Though the examiner did not ask, draw a free body what? Diagram. Mind you, the examiner told us to do what? Ignore air resistance. Do you know what that air resistance is called? It's called air friction. So let's draw a free body diagram very fast. We shouldn't even move from this page. All our answers should be here. Which forces do we have? The one going up and the one going what? Down. Which one is going down? The weight. Which one is going up? The tension. And because they told us it's at constant what? Speed. What do we know? All right. F net will be equal to 0. But it's going up. So can we take that direction as positive? And this one as what? Negative. So what do we have? Blah, 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 blah. F net equals to... Okay, let's start by writing the formula. F net equals to what? MA. What do we know? Tension plus negative what? Weight. Are you fine there? Equals to what? MA. But you know we're not looking for the weight. We're looking for the mass. Let's always read that. Do we know the tension, by the way? 1205,4 minus, can I say mg there? Which is what? 9,8 m is equal to what? 0. Oh, this is now easy. Please get me m. 1. Let's confirm. I have a 1, 2, 3. I was expecting a 4 since you're counting. 1, 2, 3. Exactly 1, 2, 3. This examiner is clever. They're just playing with numbers. 123. What's the unit? Kg. All right. I'm sure we can do 4.3 now. The helicopter now starts to do what? Accelerate upwards. Our A is no longer 0. What's our A? 2,25. Can I give you 1 minute to get me that answer? We're using the same free body diagram, right? And the interesting now is we know the mass. Get me that as what are we looking for? Tension. Get me that tension quickly. Let's get that tension. I know you can do it, so I'm not even going to say anything. I trust you like that. But we are still using F net equals to ma. T minus Fg equals to Ma. Are you done? 1, 2, 3, 9,8. 1, 2, 3, 2,25, right? Okay, share your answers. No. I don't know tension, right? Share your answers with me. Nelly, your hand is up. You've got your hand up. I have answers online 1482,15. Newtons. Can we move on? Question done, right? Lovely. Wouldn't you want this kind of things to be in your paper? We should keep driven. 1482, what? 15. 2 decimal places, newtons. Can we move on to the next one? Lovely. Everybody okay there? Same formula, acceleration, just substitute. Let's go on. All right. Learners are investigating the relationship between what? Force applied and acceleration of a block that is initially at rest on a rough surface. It means there's friction. Okay. The block is attached to a different mass piece by a light inextensible what? String, which means there's what? Tension. Over a light frictionless pulley as shown in the diagram below. Ignore the effect of air resistance. Newton's second law. We're done. Can you draw for me quickly a labeled free body diagram for the block? Where is the block? The block is the one on the table. Let's draw a free body diagram quickly. Read carefully. The block is attached to a different mass piece by a light inextensible string passing over a frictionless pulley. Four marks should be in the bag now. Or now we should be having 6. Are you done? Look at the diagram very well. Angela, you done? The object is on a surface, so there's a force there. Object has a mass, there's a force. The object is connected with another object with a rope, there's another force there. The surface is rough, there's another force. 4 forces. So, can I draw mine quickly? Let's see what we have. I'm going to have that, which is what? Normal. I'm going to have that, which is what? The weight. Object is being pulled this way. Tension. And object is moving to the right, so friction is acting to the left. So what is this? That's the weight. That's the normal. Kinetic friction and tension. Write down an investigative question. Guys, an investigative question should not be a question you will be able to answer with a yes or no. I'm investigating. Is that okay? Okay. If I'm investigating, which means I'm finding out. Check this. Can I answer an Can I ask an investigative question beginning with the word will? Once your answer is yes or no, it's no longer an investigate. Will you go home today? Yes. I'm not investigating. But if I say, how will you go home? I need to stand and see how you go home. Will you eat today? Yes. Is that investigating? No. So please, investigative questions should start with the word how or what. And we should be asking a question based on the relationship between your independent and dependent variable. So it's a question that is trying to get to the bottom of the relationship between your independent and dependent. And if you learn to read, it's right on top there in the statement. That's where what we don't like to do though. Learners are investigating what? Talk to me. How will applied force affect acceleration? Full stop. Or check. Just come here and put what is and put a question mark. 2 marks. Is that making sense? No, this is an exam paper. This is actually a grade 12 paper. What is the relationship between the applied force and what? Acceleration. It's an investigative. So if somebody says, what is? Okay, we don't know. Let's go check. Let's go investigate. Make sense? All right. What are we changing, guys? We are changing this mass piece. We're going to keep changing the mass piece. And that will be affecting what? The speed and the acceleration. It means our acceleration becomes the dependent variable because the acceleration depends on the force applied. Make sense? All right. There we go. We have a graph. Somebody is saying, on Newton's laws. Yes, it's physics. Look, guys, if this is where I stop today, I'll be glad. Whatever concept I'm going to teach you right now, listen to me, will affect you 7 times. And I'll count for you. In grade 11, graphs will affect you in Newton's laws, electrostatics, electricity. That's in grade 11. 3 times. Grade 12s, those 3 are already counted. Common variable, common. Angle that is common. Common. Then we will add work, energy, and power to it. Doppler effect, photoelectric effect, generators. Do you see it's the whole paper? It's the whole paper. So listen, what I'm going to do right now is very key. How to deal with graphs. We've done it. It will affect you also in electrostatics. Guys, the first thing I'm going to tell you is most physics graphs are straight line graphs. So let me create a small page just in between here and tell you about graphs. There are 3 ways to deal with graphs. It's right there. 3 ways to deal with graphs. But I think for now, can I just look at one, the main one? I'll look at the main one because I want us to answer that question. Look, if it is a straight line graph, we all did this from grade 9. Y equals to what? Mx plus c. Where your y is your dependent variable and your x is your what? Independent. What do you do? What is the link between this? What is the link between this? Please, I'd like you to see. This is the instruction. Rearrange your equation to match with the linear equation y equals to what? Mx plus c. Once you do that, compare the variables. I'll explain and use this as an example. Compare the variables. Rearrange your equation. When I say rearrange, whatever is on your y in the graph should come here to where the y is. Whatever is on the x should come to where the x is. You'll be able to get. Let's quickly do this in the little time that we have remaining. We have a graph. Do you notice what was on the y-axis? It was acceleration. Do you remember we said it's the dependent variable? What was on the x? It was tension. Now, because we're dealing with Newton's laws, can we say F net equals to MA? Do we agree? That's the equation we're dealing with. Can we deal with F net equals to MA? Lovely. Let's go back to the graph. Let's go back to the graph. Where did I put my graph? Look at my graph. F net equals to what? MA. Because that's what we're dealing with. All right. Now, on my y-axis, what do I have there? Acceleration. On my x, what do I have? Tension. But the main formula is F net equals to MA. Remember the free body diagram that we had? Do you remember that free body diagram? Okay, check this. If I say F net equals to MA from that free body we had, let me remind you of that check. Tension is, object is moving towards the tension, right? So can we say our tension is positive and our friction is what? Negative. Okay, watch the beauty of physics here. What will this be? T minus Fk equals to what? We all agree. But here's the problem. It's a straight line. What's on the y-axis there? Acceleration. What's on the x-axis here? Tension. You've got to rearrange so that you see that A will take the place of y. You see that T should take the place of what? X. So we should probably make A the change of subject what? Formula. Can I divide everything by M? Okay, if I divide both sides by M, what would I have? A equals to what? T minus Fk over what? M. Do we agree? Do you notice A has now taken the place of Y? All right. But I want what? T to take the place of X. I am going to split this and say T over M minus Fk over M. That's allowed in mathematics. LCD. Now, I want my T to take the place of X. Look at what I'm going to do. I'm going to split this one. This can be written as 1 over M multiplied by T. Do you agree? Because 1 times T is T. Minus what? Fk over what? M. Wait, I have gotten to my point. Y equals to what? Mx plus C. Let's check if we have everything where we want it. Do I have my A in the place of Y? Yes. Do I have my X in the place of T? Yes. That's what the graph says. On the y-axis, now I have A. On the x-axis, I have what? T. We now compare. What does M stand for here? It's the gradient. So what does this M stand for here? This is mass, remember? While this one is what? Do you know what this means? It means the gradient is equal to 1 over the mass. If we compare now. Because the M in y equals to mx plus c, which is gradient, has now taken the place of 1 over what? M. Which means if I get the gradient of this graph, I can get the mass. Are you aware that they didn't give us any information, any mass, weight, what not, no tension, blah, blah, blah? Hold on. What is C in mathematics? The y what? Intercept. I wanted to check my y-intercept. Do you notice it's a negative value? Let's go to the graph. Where's the y-intercept? It's a negative. But what is that C equal to? that C is now equal to what? Fk over, I want you to see the connection here. That everything begins from the gradient. If I get the gradient, I'll get the mass. Once I have the mass, I'll go to my graph and read the y-intercept off from the graph. I'll be able to calculate my friction. Y equals to mx plus c. Make sense? So with a graph, you'll never go wrong learning this. Y equals to what? Mx plus c. There are three things to do on a graph. This is the most important one. When I'm done with this, before we go tonight, I'll give you the remaining two. Okay. Let's answer these questions. Since we've, explained what this is all about. Give a reason why the graph does not pass through the origin. There's friction. I'm done. That's the answer. There is friction. Is that okay? There is what? Friction. If there's no friction, then the object will be moving at constant what? Acceleration. That A would be 0. Is that okay? So the reason why the graph does not pass through the origin is because of the presence of what? Friction. Okay? All right, we're done. Now, my dear learners, I want you to see 3.5 to 3.8 has everything to do with what we've done. From the graph, write down the what? Kinetic friction. Ooh, I love this. Wait, I need to do more. Write down the what? Kinetic frictional force between the block and... Let's do something. We spoke about y-intercept now, right? Can we deal with x-intercept just before we start answering this question? What is our equation? I'm going to clean all of this. This is where you see maths and physics just loving each other. Hold on. What is on? Please look at this. What is on the x-axis? Tension. How do we find... we find our y-intercept, right? How do we find the x-intercept? Make y what? 0. What is my y? Acceleration. Let's make it 0. So what are we looking for? We're looking for what? X what? Intercept. Which means acceleration must be equal to what? 0. So what do we have? 0 equals to what? T over m minus what? Fk over m. Do we agree? Can we move the Fk over m because it's negative? What do we have? Fk over m is equal to what? What can you tell me here? Do you know the denominators can just cancel each other? So what do we have left? Wait. What are we looking for? X-intercept. Makes sense? It simply means that my x-intercept right here is my frictional force. Because that whole line is what? Tension. That point is my what? Because we looked for x-intercept, right? So we said x-intercept, tension force, is equal to what? The frictional force. Remember, all of this is what? Tension. So at this point, that is my friction. We're going to read this off quickly. Let me do this so that we have a bigger view, especially for those of us that are at home. Oh, this is so much physics in one night. 1 second, just to make that bigger, and then we calculate. All right, I just want to make the graph a bit bigger so that we can all see clearly, because we're going to read a lot of things off from the graph now. And I know that some of us also struggle with getting values from a graph. So let's help each other sort that out. Awesome. Okay, great. Let's run through. Guys, are you okay with my analysis saying that the x-intercept is now my what? Friction. Can we read this value off? Let's see. This is 0.5. In this graph, there are 10 boxes. What is the value of one box? Okay, check. Between two black lines, what do we have? 0.5, right? We okay? And there are 10 boxes. So what is the value of one box? One box, one tiny box will be what? 0.5 divided by 10. What would be the answer? 0.05. So each box is what? 0.05. Now, what is this? 1, 2, 3, 4. It's on the fifth one. Make sense? If it's on the fifth one, to make it easy, I would just normally say 0.05, which is one box, right? How many boxes do we have? 6. Multiply that by 6. What do you have? 0.3. Add that 0.3 to 0.5, because on the x-axis, it must always what? Increase. So what's your answer? 0.8. We're done. Talk to me. Guys, did that make sense? You'll be surprised how many people don't know how to read that value. Guys, did that make sense? First, you get the value of one box, because we need the same thing when we calculate gradient now. Get the value of one box first, or rather, we find the margin between the two black lines. We know it's 0.5, right? How many lines, how many boxes are there? 10 of them. So 0.5 divided by 10 will give us 0.05. Each box is 0, if you don't want to do what I did, you can just add 0.5 plus 0.05. That is 0.55. Then 0.6, 65, 7, 75, 8. What question were we answering, people? We were dealing with which question again? From the graph, write down the what? Frictional force. And we said it's our what? X-intercept. What's your answer? 0.8 newtons. That is 3.5. 3.6. Now, do you see that if a learner does not know what graph means, forget about all of these questions. Just wave it bye-bye. Can we calculate the gradient of this graph? Let me give you a bigger one. There we go. Gradient. Don't even stress. Already we have 1 point. 0.8 and 0. Are you aware that? The x-intercept. Do me a favor. I want us to read off this point. I'll give you a moment. Read off point C for me. The y-intercept. Now, please, the dimensions are different now. The calibrations are different. Whatever I did on the x, you need to do on the y. Get me that reading. I'll give you 1 minute. Negative? Okay. I have a negative 0.6. Check again very well. Check very well. Between two black lines, there are 10 boxes there. Okay, for most of these graphs. So read the black line very well. On the horizontal, on the vertical. Quickly, let's check. Let's check. Yusuf, I should use 1 and 2 You can, but you still need to read out 1. I see 2 is easy to read. Oh, okay, I see what you're doing. You're cheating there. But I want you to read that value for me. Don't come with your foot self here. All right. I see what he's using this point quickly. Okay, let me quickly make a point here. Please, when you read this, don't just read the black points, because we're drawing what you call a line of best fit. Don't go with the black dot if the black dot is not on the line. We're reading points that are on the line. This time around, in this case, perfect, that black dot is on. Sometimes you'll see a graph, the black dot is in a perfect spot, but it's not on the line. I don't know if you've seen such graphs. It's on a perfect, square there, but it's not on the line. Once you do that, mark is lost. All right, 2 and 1, but I want this value, because I want us to, don't run away. I want us to learn how to read. Let's see quickly. Do you notice that this is 0? We don't know this is 1. Automatically, what is this? 0,5. Oh, so basically, it is the same dimension now. The same. So it is 0,05. So what is this? Negative 0,5. We have just 2 boxes. So what is the value of C? Negative 0,6. Lovely. Can we use that to get our gradient? Remember, gradient, you can use any 2 points, even the 2 and the 1 that Yusuf spoke about. All right. Please write down your values, y2 minus y1. Everybody calculate. Now we have 3 points. It depends on you. Here, what's our coordinate? X is 0, y is negative 0,6. We did get our x-intercept, right? X-intercept, we got 0,8. And we know the y value as what? 0. We can also use this point. It's a perfect point. All right? The graph passes through 1 or x is 2, y is 1. Please get me gradient, whichever point you decide to use. Type your answers in. We're finishing now quickly. ESCOM is going to do their stuff. They are the bosses. Come, give me answers. What do you have? Gradient. y2 minus y1 over x2 minus x1. Come on. Huh? 5 over 6. Can we confirm? Please give me your answers quickly. Everybody, give me answers. What are my coordinates? Let's write it down. When x is 0, y is negative what? 0,6. We got that one right. Then when x is 0,8, we got what? Y as 0. When x is 2, we got y as 1. Any of these 3 points, collinear, analytical geometry, should give you the same value. So just check. y2 minus y1 over what? x2 minus x1. Okay, let's work it out together quickly. Do you remember those values? I need those values. We're looking for gradient. Ooh, my arrangement here is messed up. This thing must come here. Graphs. Okay. All right, let us then look for y2 gradient. M equals to, we're finding the slope, right? Remember? Gradient. y2 minus y1, which is a2 minus a1 over what? Tension 2 minus tension 1. Give me your values. Give me a2. Any values that you have. Give me A2. I want A2. What did you use? 1. Minus negative 0,6 over 2 minus what? 0, I think. What's your answer? Huh? I thought you were done. 4 over 5, which gives me what? 0,8. And you got what? 5 over 6. And 5 over 6 still gives you what? 0,84. All right. So are we okay? Any 2 points you use should get you the same what? Answer. Just taking from my mouse. All right. So this is giving us 0, what? 8. You get your 2 marks there. Now look at 3.7. It looks as if it's not going to make sense. Calculate the mass. Do you remember the analysis we did? What did we say? That the gradient is equal to 1 over what? The mass. This is where it's going to catch up with us. If we didn't know. So, but now we know. So what do we say? 0,8 equals to 1 over the mass. What is the mass? You do the maths quickly. Let's see your maths. Do the maths quickly. We're done now. Tiamo. C. Clay. What's your answer now? What's your answer?
1,25 kg.
Confirmed? 1,25 kg. Yeah. All right. Because if you have 4 over 5, now it's 5 over 4. It's the reciprocal. All right? 1, what? 25. Do you see why it's important to know what that means? Now look at 3.8. Write down the mathematical expression represented by what? The y-intercept. C on the graph. I think we did that. What was our C? Fk over m. But it's negative Fk. Do you remember where that came from? Where is it again? What is our C? Our C, oh, I missed a negative here. C is what? Negative Fk over m. A learner who doesn't know this is in trouble. Is that okay? So you must know how to deal with your graphs. I said I'll give you the last 2 points quickly. 2 minutes, and then I'll release you. So what is our first one? First one is what? Rearrange, right? Okay. So, quickly, graphs. Number 1, we said what? Rearrange a straight line graph. Rearrange in the form of what? Y equals to mx plus c, especially if it is what? A straight line graph. Number 2, multiply the axis. Multiply the axis, and this represents the area. I'll do more of this in our next session because I'm going to look for questions on electrostatics that require this. All right? And number 3, divide the axis. I should actually say E. And this gives us what? Gradient. I want to show you something here quickly on this divide. Now, this multiply and divide doesn't work in all graphs. In this particular graph, what do we have? We have A, we have what? Tension here. And the graph is like this. If we multiply, remember this is a force. If we multiply, we're going to be having A multiplied by what? Tension force, right? Let's say Ft. The question is, does this formula exist? Check this. F net is equal to what? Ma. Do you notice from that formula, there's no way I'm going to say A multiplied by T. There is no way. There's no magic you're going to do. There's no maths. Once you start saying from here, you can get A multiplied by force. You're no longer doing maths. You're doing space maths. Okay. What about the division? Do you think it would work? Let's see. What is A over force of tension? Can we get A over force there? Let's see. Can I divide, okay, I want A over FT, right? Can I divide both sides by A? What would I have? F over A equals to what? M. Over what? 1. Can I reciprocate it? What do I have? A over F equals to what? And that's what we got. That the gradient is 1 over M. All right, guys, I will stop here. This is, I knew we were not going to finish because I kept adding, you know, when I was preparing these slides, I kept adding questions, kept adding. If you check, look, I added this one. Then I added, because these questions are beautiful, I couldn't just let them go. They're beautiful. Then we have our universal gravitation, okay. I had a multiple choice. Then I have my what? Electrostatics. I have electrostatics. Check. I kept seeing things. I couldn't let go. I have that. Look at this one with string. I just couldn't let go. I added this one. They're just too nice. I don't know which one to drop. And I still need to add the one of graphs for electrostatics. So that's why I decided to say this would be what? Session number 1 for our physics part. I'm going to try to just do one more for session 2. All right. Yes, you're saying? Yes, please. Yes, please. It's all revisions. When I'm doing maths revisions, you are attending. When I'm doing physics revisions, you are attending. Okay. All right. For those joining, we do have weekly maths and science extra class. And this is what you enjoy. This level of information and explanation. It's just beautiful. And you can also have access to all the recorded lessons. If you need information, just send a message to 0817442103. We do have groups. Okay, I see Simone is asking for the groups. Just send a WhatsApp message to that number. You'll get onto the groups. You can also make an inquiry about the extra classes. I will be posting this on YouTube so that everyone can have access to it. It's quite beautiful. I enjoyed myself, you know, so that everyone can have access to it. But for you to know when I'm posting, just go subscribe. All right? Subscribe, like, comment, share the lessons, and tell everyone that there's something happening. Help someone. Someone might just need this lesson. Okay. But anyway, good night, everybody. For more information, please 0817442103. Good night. Thank you for joining.